All right, hello everybody. Thanks to Jeff for another great introduction. Great to see you all again for another webinar from Determinate Systems. My name is Luke Perkins, and I'm speaking to you today from the lovely city of Prague in the Czech Republic, or Czechia, as I guess some people call it now. And this time I'm going to talk to you about something very near and dear to all of us here at Determinate System, and that is Nix flakes. So first, just to kick it off, I want to talk about what was, from our perspective at least, the dark ages before Nix had flakes. Some of you have probably heard a lot of this before, but I'm just going to go over it really quick. So the biggest problem with Nix prior to flakes, I think, was that dependencies were unpinned by default. And this produced a lot of indeterminacy, where trying to evaluate the same Nix expression produced different results on different machines for a variety of reasons. So if you're looking at older Nix code and you see things like import Nix packages to create a version of Nix packages, what's happening here? Well, like the question you have to ask is to which revision of Nix packages? You just have this like diamond dependency like representation thing. The thing is, it depends on the machine doing the evaluating, and it depends on to which revision of Nix packages that system's Nix packages channel is currently pointing. Now back in those days, people did come up with ways of pinning Nix packages either inside of their Nix code by using the fetch tarball function to pull a specific revision, or by using external tools like niv or niv, npins, and a few other things. But the problem there is that you ended up with a profusion of standards and mechanisms. And even when you would pin to specific revisions of your dependencies, there'd be no guarantee that those dependencies themselves were pinning their inputs. So what happens is that the more complex your dependency tree, the more potential sources of indeterminacy you might have lurking in there. And in order to be sure that one of your dependencies is pinning its inputs, you would probably have to go and check. So you'd have to look, go to the GitHub repo and check it out. Which is not super ideal in computing, broadly speaking. The result is something that I would call a compounding indeterminacy debt, where the more ambitious your use of Nix and the more ambitious your expressions and the stuff you're trying to build, the more indeterminacy you end up with in your Nix code base. Now, or not so much in Nix code base, but more in your Nix evaluation path. Now, lack of pinned inputs may not be a huge deal for smaller projects, but it doesn't really scale inside of an organization. And it's just not the kind of paradigm that you want to build on over time. And it's not the kind of paradigm from our perspective that fulfills Nix's great promise. On top of that, there were some ergonomic problems that I won't touch on too much today, but I will mention them. One is lack of discoverability, where you don't have commands like recent commands like nix flake show or nix search to delve into flake outputs. And another ergonomic problem is that there were these file-based conventions for flake outputs, or rather, not for flake outputs. There were file-based conventions for exposing exposing attribute sets and exposing derivations. So you'd put your package outputs in a default.nix file and then build it with the Nix build tool. You'd have development environments defined in a shell.nix file, and you'd activate them using this Nix shell tool. And there were lots and lots of other conventions, and oftentimes not a lot of consensus around how to do things. With the dark ages out of the way, I want to do a quick refresher on what flakes are so that we're all on the same page. So a flake is a directory of code or directory of files. They don't all have to be code, with a flake.nix at the root. And that flake.nix file does essentially two things. So first, it specifies flake inputs, which can be either other Nix flakes or sometimes non-flake sources like Git repositories or local directories. And these inputs instruct Nix to pull in anything you need, and these, not just yet, and these inputs instruct Nix to pull in anything you need from outside the directory in which your project lives. Now, not all flakes have flake inputs. So Nix packages, for example, has no inputs, and it just builds a whole world of Nix stuff out of itself in this magical kind of sui generis way that takes a lot of work. But most flakes have some inputs, like Nix packages and sometimes some other stuff as well. And we hope more and more stuff will work this way over time. Second, flake.nix files specify flake outputs. Now, outputs can be packages or development environments or NixOS configurations or many, many other things. They're basically any Nix expressions that you want to share with others. Usually derivations like packages, but sometimes other things like constant values that might be useful somewhere else. I think from my perspective, one way to think of flakes is that they're kind of like a function. And I'm grimacing in the emoji here because functional language purists will probably object, but I think it's a decent analogy. The flakes take some inputs and they expose outputs. Other flakes use those outputs as inputs, and then those flakes expose some outputs, and so on to any number of levels of depth. And I've certainly encountered flakes that with like 8 levels of depth. And basically this all produces an indefinitely large chain of Nix stuff, Nix expressions. Some of it's buildable, some of it's scaffolding, some of it is functions that are required here and there. Now, you cannot discuss flakes without talking about the flake.lock file, which works basically just like lock files in other languages. If your flake has any inputs at all, those inputs are pinned to specific revisions in the lock file. So if you have a flake.nix in a directory that specifies inputs, but there's no lock file yet, then just about any Nix command like nix build or nix develop tries to create a lock file. And that's because flakes have pinned inputs by definition. If you have unpinned inputs, then you're just not dealing with a flake by definition. Flake.nix and flake.lock are an intrinsic pair. And when you're dealing with these expanding chains of flakes depending on each other, this pinning becomes ever more important. One of the benefits of having a flake.lock file with pinned inputs is that you get convenient commands like nix flake update baked into Nix rather than delegated to some external tool. And so the ergonomics of pinning become an essential part of the package, no pun intended. So I'd like to explain what's happening in flakes a bit more abstractly for a minute here, because I think it actually ties in pretty well to some functional programming concepts. Now, I want to break down what Nix does when it's realizing a derivation into some basic component parts. Now, I think you can understand this process in functional terms. So in functional programming, you have a function that takes in some input and it produces some output, and it does so in a determinate fashion. And if it does so in an indeterminate fashion that it doesn't belong, then it's technically, like literally, not a function. In Nix, your function is called a derivation. So the fn right here is a function. It's called a derivation. And a derivation is a data structure that you create using the Nix language. So the input to your function, denoted by S1 here, is generally some initial file system state, but it also might be some other data, some other Nix stuff. And the output of the function is some resulting file system state. This is a heavily simplified version, of course, but this is basically what it boils down to. This is really like the beating heart of what Nix is up to. You have some state, maybe some data. You want to create a package or a Docker container or an entire Linux system. And so you create a derivation that does that. And if you play your cards right, you've done something pretty magical that ad hoc approaches, including bash scripts and duct tape and following along in the README to brew install, generally fail to do. Now, flakes actually do something pretty similar to what Nix does in its core functioning. They take some flake inputs, well, usually with exceptions like Nix packages, and they also take something that I'm going to call self for the purpose of argumentation here. And self is the file system state of the flakes directory, plus some Git metadata that is often helpful, like the Git revision number and the last modified date. And you take those inputs and you take self and you produce some outputs, or you expose some outputs like packages and development environments and all of that good stuff. So just like Nix itself, when it's building file system state by taking a derivation and converting that into some kind of resulting file system state, flakes perform a similar function in both senses of the term. And the same way that in functional programming, you can take the outputs of functions and pass them on to other functions and produce more outputs, flakes form a link in a chain. And that chain can grow to be as big as you need it to be to suit the use case at hand. But what remains true at all times is that NICs can reconstruct that entire prior chain from the standpoint of any link in that chain. And so I believe that the problem that flakes solve is what I'm going to call the distributed input problem. That is, flakes enable you to always determinately reconstruct the entire set of inputs pulled in from elsewhere to a given flake. And because flakes are always pinned, the entire input graph becomes deterministic. And so the same way that when you're building something with NICs, you're realizing every subderivation inside the dependency tree until you finally get a final output on the other side, flakes enable you to do that across as many inputs as you need. And not only do flakes do that for NICs, you can even refer to that entire input graph with a single string. Now that string only represents the final node in that graph. So that might be, so you're building something that relies on a bunch of stuff 5 levels deep. It's only your thing that gets a string representation, but you only need the final node, or you only need to represent the final node because every prior node comes along with it. So those strings can represent flakes in the local file system. They can represent flakes in your NICs registry, although we encourage doing this only if you're doing, running commands on the CLI. Those strings can represent flakes hosted on Git forges like GitHub and GitLab. And those strings can represent flakes hosted on special forges like our own FlakeHub, which provides support for semantic versioning, as in the example here. So you see the little version constraint of 0, which means basically give me whatever is considered stable. So I would say if you come away from today with anything, it's that flakes solve this distributed input problem in a way that NICs without flakes doesn't, and in fact cannot, at least not elegantly. On a more somber note, flakes don't solve everything in NICs, of course. While flakes do solve the input problem, they do not solve what I would call the output problem. And that is kind of the other side of the NICs equation. So they don't solve the problem of malformed derivations. They don't solve the problem of accidentally introducing indeterminacy into your derivation logic. So flakes won't prevent you from, for example, writing a timestamp to a file that ends up in the NICs store. The bad news is that solving the output problem is well, that's on you. Sorry, there's the emoji pointing at you. So flakes can give you the entire determinate input graph needed to build some other thing, but they can't take every foot gun out of your hands, nor, I don't know how they conceivably could. The good news, though, is that there are thousands of people working every day to solve the output problem. So they're improving libraries and NICs packages, they're releasing new packages, they're building new derivation frameworks for specific language and tool communities, so on and so forth. And that's the beauty of being inside such an active and expansive ecosystem. But I do think that the input and output problem, although distinct, are intimately related, and then it's a whole lot easier to produce the outputs you want inside the flake universe, which is the universe of determinate inputs all the way down. So in addition to not solving every NICs problem, flakes also come with some problems that I believe to be sort of intrinsic to the flake paradigm. The most commonly cited one is that flakes involve a lot of copying file system state into the NICs store. And flakes involve this because, like I said before, flakes need the entire input graph. And so when you build something in a flake, you need to fetch every flake in the entire input tree that's required and write all of them to the NICs store. There is a feature called lazy trees that's in Determinate NICs, that is in our downstream distribution of NICs, with a pull request currently open to the upstream project. And what lazy trees do is they make NICs a lot smarter about what file system state from the current flake needs to be copied into the NICs store and when, which in turn makes NICs much more efficient, especially in larger repos with a lot of file system state. NICs packages is a great example, but also, organizational level, like mono repos are a great example. Like I once worked in a mono repo that was like 50 gigabytes. And of course, lazy trees would be absolutely vital there. We do hope that lazy trees lands in upstream NICs sometime soon, because we've seen speedups of 2x to 5x in some scenarios. But the thing is, Even with lazy trees, people are often surprised at how much work Nix needs to do to function properly, because when compared with tools that are a bit more fast and free and loosey-goosey in how they work. And unfortunately, there are always going to be some built-in limits to how fast you can make disk I/O. It's a bit unfortunate, but I think that it's the price of correctness, and I think it's a price that we need to continue to pay inside of this particular paradigm. Another bit of less somber news is that when you build something with Nix, you only ever fetch the flake inputs that you need. So instead of aggressively fetching every flake input in your dependency graph before anything is ever built, Nix is smart enough to do this only on demand. So there was recently an Nix command added called Nix prefetch inputs that will do precisely that. That'll fetch all your inputs before you build anything, which can be useful in some cases, but Nix does not do that by default. And yeah, so basically what Nix does is it always has total knowledge of the full input graph for a given flake down to the git revision in each input. But it only grabs those inputs when needed, and that's vital whenever you're dealing with larger input graphs. And that in turn is vital because we are expecting to see these graphs get bigger and bigger over time in the ecosystem, or rather as the ecosystem on the basis of flakes decentralizes away from just having everything in Nix packages and starts to put things out in these kind of distributed trees. With all this theoretical stuff behind us, I should say a little something about the relationship between determinate systems and flakes. You weren't going to get out of this webinar without hearing a little something on these lines. Well, we as a company this is probably controversial, but we are essentially the flake company. And what I mean by that is that there are other companies that use flakes and build stuff that can benefit people who use flakes. But we at Determinate Systems have been out there in the public sphere preaching the virtues of flakes for the entire existence of our company. And we've been unabashedly vocal about the potential consequences of not taking full advantage of this historical moment to make Nix what it really could be. And so we've written blog posts about why we think that flakes are already stable, and we've been active in all kinds of communication channels arguing in favor of flakes. On the product side, we have a downstream distribution of Nix called Determinate Nix, which is a lot like upstream Nix, but with some crucial differences. First and foremost, flakes are considered, well, not just considered, they're declared to be not just stable in determinate Nix, but they are the way to do things. So we're in the process of deprecating Nix channels. And this is, as far as I can tell, the first tool in the ecosystem that is really structurally, fundamentally all in on flakes in every conceivable way. As I mentioned before, Determinate Nix has support for lazy trees, and we've rolled out support for this to 100% of our users. So if you download Determinate Nix, you're going to be using lazy trees starting now. And the benefits for the use of flakes have been quite transformative in many cases. We're also beginning to add support for parallel evaluation to a wide variety of flake-related operations in Nix, which should slowly but surely improve the ergonomics of flakes over time, especially for operations like Nix flake check, Nix search, and a couple others, which have historically been uncomfortably slow, but those days are coming to an end. We also have a platform called Flake Hub, which is a place where you can publish releases of your Nix flakes. It's a little bit like GitHub, but tailored to the very, very specific requirements of people who use Nix and flakes. So Flake Hub has support for semantic versioning for flakes, which can make your flake input update operations much more smooth and reliable and much more in line with best practices in other language communities. It also has a concept of private flakes backed by federated authentication. So as I said before, flakes always involve the entire pinned input graph, but you don't always want that entire graph to be public and accessible to anybody who just so happens to have the right flake reference at the end. And so private flakes add a vital feature to flakes for security-minded organizations and even for smaller orgs, I think. And finally, Flake Hub offers a bunch of flake discoverability goodies like search, generated landing pages, and a CLI tool for listing flake releases, and amongst others. None of these things are necessary to make flakes work, but they do add what we think are some missing pieces to the flake paradigm to make them more useful in contexts that go far beyond things like personal projects. And you can read more about these offerings on our docs site at docs.determinate.systems. Oops, I'll let that sit for a quick second so you can make note of it. In the future, we have plans to continue innovating really hard on flakes. So we published a prototype of flake schemas a while back, and we intend to deliver this sometime in the next couple months. Flake schemas are basically like custom output structures for flakes. So I talked about this distributed input problem. This is kind of a I think that this obviously doesn't necessarily solve this problem on its own, but it assists in discoverability in such a way that I think could be really helpful. So at the moment, flakes have some standard conventions with output names like packages, dev shells, NixOS configuration checks, and so on. What flake schemas would do is they would enable you to create your own custom output types, which should improve discoverability substantially and could even chip away at what I call the output problem earlier on. So if you're using flake outputs for Docker images, for Nix Darwin, for Home Manager, for I don't know, you're distributing WebAssembly modules or something like that. We know that there's all kinds of like project level or project specific things that you would want others to be able to discover. You want to be part of this grand Nix universe out there, and we think that this is going to go a long way towards making that better. You can check that out on GitHub at /Determinate Systems /flake schema. So we have an initial set of schemas, and you can also see there how to write your own and all that good stuff. Sparse lock files are another thing we'd like to add. I talked about input graphs before, and flakes will always think in terms of the full input graph, no matter what level of depth that graph goes to. But sparse lock files would be a way of encoding only the truly necessary input information in flake.lock. So Nick, let's say you specify like 10 flake inputs, but nothing in your flake actually uses 9 out of 10 of them. Well, then only the one that's actually being used would be registered in the lock file. So it wouldn't necessarily change the input graph per se, but it would make Nix much smarter and much more parsimonious at how it represents and encodes that input graph in the lock file. Another fun feature that we'd like to bring to flakes is configurable flakes. Elko talked about this at Planet Nix a while back, and you can check out a video of his talk at determinate.systems/video/configurable flakes. It's pretty slick, I'm not gonna lie. Right now, flakes are completely self-contained by design. So if you create a flake.nix and that's sort of final. It just, it does what it does, and you can't supply any additional information on your own. Configurable flakes would enable you to do precisely that in a type-safe way and in a deterministic way that opens up all kinds of fun possibilities and could improve the ergonomics of using Nix pretty substantially. So definitely stay tuned for developments there. Yeah, thank you, everybody. That's it. I think it was a little quicker this time than usual, but that'll just give us more time for Q&A. Definitely stick around. Reach us if you want to. If you have questions, comments, feature requests, whatever, reach out to us at hello@determinate.systems. You can talk with us on Discord, determinate.systems/discord. And yeah, we hope to come back at you with the webinar in the next couple of weeks.
Right on. Fantastic, Luke. Thank you so much. That was great. I learned a few things too, even though I'm now a veteran here. Okay, so we have some questions that have already come in. If you have any other questions, if you were in the webinar and want to ask some questions, please drop them in the Q&A. Like I said earlier, Ilko is also in the webinar, as well as Graham, so both of our co-founders. So if you have any questions for them specifically outside of Flakes, you can use the webinar chat for that. So Luke, I'm going to throw you some questions, and I want to start out kind of high level. Somebody asked about flakes being experimental upstream,
Mhm.
despite being relatively mature, which I think you've kind of demonstrated here. Can you talk? Do you have any idea why they're still experimental upstream?
Yeah, I mean, I think that there are competing definitions of what stable and experimental means. We think that we acknowledge that there are things in flakes that could be improved. We're working on improving those things. I mean, like literally every single day, doing whatever we can. But I think that from the standpoint of some people on the Knicks team, and of course, Elko is one of 6 on the Knicks team, and they try to operate on a consensus basis. I think their position is that flakes just aren't perfect-ish enough to be considered stable. And we just fundamentally disagree. We look at the thousands of people using them. We look at rates of adoption. We look at all kinds of key indicators, and we say that the revealed preference of the Knicks community is to regard flakes as being stable. And stable, of course, doesn't mean that we that we wrap it up and into a nice package and throw it over the fence and never think about flakes again. There's all kinds of iteration that we can do. Yeah, it's almost like a semantic difference that's become a community split. And we think it's unfortunate, and we're just not really quite sure how to get around this impasse. And it was precisely our desire to keep building and providing and innovating that we decided to just to have a downstream distribution in the first place, to declare flake stable and see what happens. And thus far, the proof is in the pudding, and I think that has proven to be the right move.
All right. Now I want to drop down one more level. Talk a little bit about, can you compare and contrast flakes to like an npm package or like a Python package? Like how, like obviously they're not the same, I don't think, but can you do a little bit of a comparison there?
Oh yeah, that's I mean it's a great and not great analogy in a lot of ways. I guess I'll start with the not great. So when you pull in gosh, that's a tough question because an npm package can also, it can be JavaScript code that you would use in other JavaScript code, but there can also be all kinds of other files and stuff in an npm package that aren't JavaScript or TypeScript or whatever. So in that sense, I think that the analogy holds. I think one thing that makes Nix Flakes fundamentally different, though, is just the fact that they have fully contained build recipes in them that you can use to build arbitrarily complex file system state. And that's something that, an npm package is, you're going to run npm install, and that's going to enable you to insert, take some text and insert it here and import and like use a function. And that's all great. And flakes aren't not that. They kind of are that. But I think just what makes it different is just the nature of Nix and what it does and what it solves. And that is, like I said, it's building real stuff. And at the end of the day, npm packages are also involved in the building of real stuff, but at one layer further removed, I would say. So that's not a super great answer. I mean, this, like I said, the structural similarities are there. What's different is just that Nix has a completely different goal entirely.
Yeah. So I want to drop down into something really specific, and this came probably in the first 10 minutes of your presentation when you were kind of defining what flakes are. And so the question is self the directory? And this person that asked always thought it was the flake itself.
Yeah, so self has self is this is getting a little bit in the weeds, but self does encapsulates like a good amount of information. So if you use just that name self as a path, then it refers to the root of your flake. And so if you can, self, if you have like a string and you take self / bin or something, that's going to represent the bin subdirectory of your flake. So self, it both does represent the root and represents the entire file system, but also when you do self dot, it has all these attributes in it. So self dot last modified date, self dot revision, self dot out path, and a bunch of other things. And so that's what so that's why I went when I said before that self is maybe not a great thing to use inside that inputs plus self leads to output thing. But yeah, self's a little bit tricky. It does refer to the current flake, yes, but bear in mind that what the flake is both the file system state and this metadata.
Yeah, got it. All right, so we got a bunch more questions coming in here.
I'm gonna take
Yeah, you
one
want
from
to?
the chat. Yeah.
Please do.
Hey Sam Rose. If we drop Nick's channels, what is a good way to reference inputs where we know that packages have been tested and released versus just any branch of a flake-based project? Might help to have some convention for people to publish fully tested release package sets versus other branches, etc. Question mark. Yeah, that's interesting. Because obviously, Nicks and flakes by themselves don't have any intrinsic way to communicate that. Like, you can't say Nix build, only something that's been sufficiently tested. Elko flake up. But the thing is, like, I could imagine maybe somebody creating a flake schema where you don't just say Nix build packages, you say Nix build secure packages, or as have secure packages dot system dot OpenSSL. I could imagine a community convention arising around that. But yeah, the short answer to that question is that Nix doesn't have any intrinsic ways to do that. That would be something that would arise. I mean, just as in the Nix ecosystem now or previously without flakes, this was a question of community convention, what we consider to be authoritative and not authoritative, secure and not secure. And I don't think that the flake universe would be able to overcome this problem without it being essentially a social problem and a problem of trust and communication and information and all of that old-fashioned, not functional programming stuff.
Yeah. Since I am the sales guy at Determinate, I will add, I do believe that Flake Hub does solve this, right? Like Flake Hub is how we have, fully tested release package sets available as reference inputs, right?
Well, yeah. Well, I mean, Flake Hub doesn't solve the problem on its own, though. You can put out a flake release on Flake Hub that has packages that are not thoroughly tested. And so I feel like the problem of trust that we have a certain degree of trust in Nix packages and Hydra and things like that. I consider that more of a social thing. I'm not sure. So I'm not sure what specifically Elko and Graham are referring to when they say that Flake Hub solves this problem directly. It could be that there's just a terminology misunderstanding at work here.
Here's another one. Can Nix Flakes be a complete Docker replacement?
I absolutely think so. Yes. At least in terms of building Docker compatible images. I don't think it's a replacement for like the Docker runtime and things of that sort. So it's not a solution to starting containers and fetching them from a registry or something like that. But yeah, I have never come across a Docker file or a Docker container that wouldn't be built probably better by Nix. So I think that and that doesn't mean that Docker as a tool becomes useless. Like I said, I use it all the time. Docker run, Docker pull, like all of that good stuff. But I personally build all of my Docker images with Nix. That's what we do at Determinate Systems for all of our core services.
What about Flakes and Home Manager? Like, what do you need Home Manager for if you're using Flakes?
Well, it's a different problem. I mean, Home Manager is Flake compatible. I mean, I use Home Manager myself. For me, my Home Manager configuration is a Flake is an output from a Flake. Home configurations dot whatever. So yeah, I don't quite understand the question because Home Manager is a tool for deterministically building a home environment for a system, including dot files and included packages and SSH configuration and all of that good stuff. And yeah, I mean, you can output home manager configurations using Flakes. You can take in
Mhm.
all the inputs to your home manager configuration as Flakes as well, and that's certainly what we recommend.
Yeah. And I see that somebody in the webinar, Sander, dropped a link to a discussion in discourse at
Oh,
nixos.org
legacy pack.
that explains legacy packages. But I see the URL also says two ways to write a home manager flake. So we might address both of those topics. All right. So I think
Yeah.
we're at 45 minutes after the hour, which is when we plan to wrap up. So I guess one last question I wanted to can you imagine or a situation in the future where some flakes will work with determinate nicks but not vanilla nicks?
Um, I mean, in the future, yes, there will be discrepancies from time to time. For example, recently we introduced a feature called build time flake inputs, which basically, if you specify, and this is good for using things like Git repositories and others as flake inputs that they are by definition only fetched at build time and never before, and this can make evaluation much faster in a lot of cases. These do not yet exist, or they're not currently supported in the upstream project. So if you used a build time only input in a flake, upstream Nix would not understand it, but determinate Nix would. This is something we are going to upstream this, and we certainly hope to resolve that I don't know, slippage, I guess you could say, over time. But it's certainly not our intention for there to be like indefinitely prolonged differences of this kind. We think that compatibility is really like a core focus for us.
Yep. Yep. All right, maybe one last one. There was a question in the chat to everyone about NixD and being open source. It's possible in the future. We can't speak to that officially right now, but I think there's a second part to that question. As the community has flake parts, flake utils, etc., for making flake usage less boilerplate, does DeadSys have a preference on that?
My strong preference is to use none of those.
Okay.
I find flake parts really, I find it overwrought and over-engineered. I've never personally had a use for it. If you have a use case for it that you feel like that where it makes a lot of sense, I say go for it. I mean, I certainly like wouldn't discourage you. I personally have never come across a use for it. As for flake utils, I think that you can usually get everything you need from flake utils in like two or three lines of plain old Nix code. I think that so we at Determinate Systems, we don't use flake utils. We tend to just have like up in the let block prior to outputs, we just have like the 3 lines that gives us per system Nix packages and all of that good stuff. And what that means, and yeah, it's a little bit boilerplatey, but it also means that when we're constructing that big input graph that I keep talking about, very often you look at flake.lock representations of these input graphs and you see flake utils like scattered throughout, and we just don't think it's necessary. So that's all. But if it works for you, keep using it.
Yeah. All right. So with that, I am going to wrap us up. And if we didn't get to your question, we are very sorry. Please feel free to email us at hello@determinate.systems or go to our Discord, which we have an easy link to. It's just determinate.systems/Discord. Our team hangs out in Discord. So all the members of Determinate Systems are there. We can do lots of discussions. Unfortunately, we don't have time to get to all the questions here, but we can follow up via email for some of these. And please, again, reach out to us. So thank you all for attending today. We really appreciate your interest in what we're doing. And I will send this recording out to everybody by tomorrow. So have a great day.